Hi everybody, I'm Ian Cunningham from Vets GB. Welcome to this episode of Engineering the Jigsaw, foundation level episode number 10, How has the Jigsaw evolved? In this episode, we're going to discuss how vehicle EE systems have changed over time, very roughly. We're going to use the concepts that we've introduced through our foundation level episodes so far to illustrate some possible snapshots in time. And in particular, we use some concepts from F3 networks in vehicles. Possible because we obviously can't give exact details of any particular vehicle. So we're using made up examples to try to give you an understanding of how things have altered in vehicle EE systems. To do this, we're going to revisit our example of traction control that we've used a number of times through the series, and we're going to consider the changes that a simplified vehicle EE system goes through from the 1950s up to very recent times. So, make sure you're familiar with the concepts we cover in episode F3, Networks in Vehicles, before we move on into today's episode, where we're going to talk about how an ABS functionality is able to detect spinning wheels and let the engine control system, the thing that's providing traction power, tractive power to the vehicle, to please reduce the power and thereby regain traction. And this is our traction control function. We'll think about how this has evolved possibly, and how in a future episode we'll look at how it can evolve even further. So let's begin in the 1950s. And in this vehicle, there are no ECUs and no networks. And really, this was the case for the first 70, 80, 90 years of vehicles. So the very first car was invented in the very late 1880s in Germany. And yeah, the electrics, when they arrived, we had lights, we had a starter motor to start the engine, and really nothing else. So if we brake too hard in this vehicle, we're going to skid. If we accelerate too hard, we're going to spin the wheels. Not especially interesting from our perspective when we're all about EE systems. So let's move on to the introduction of electronics into vehicles, roughly the 1980s. So we're going to introduce some electronics for skid control initially. So we have an ABS controller, and of course we're going to wire this up to various sensors. So for example, the sensors that detect if an individual wheel has stopped turning, so if it started to skid. And of course the ECU will also be linked, our controller I should say, maybe even at this point, will also be linked to various actuators in the vehicle. In the case of the ABS controls, it's probably actually built into a valve block, where the valves are that modulate the brake pressure. It's called the brake modulator unit, and this is what allows the anti-lock braking system, the anti-skid braking system, to release the braking pressure to an individual wheel if it starts to lock. And of course, we may have other control electronics in the vehicle at this point in time as well, and they could be really simple. Each one will certainly only perform a single function, such as our anti-skid braking system. We may also have a fuel injection control, little box for that, and ignition control, of course, connected up to the spark plugs. Sometimes these controls are so simple that there's no software in them, so we possibly wouldn't even call them an ECU, as I accidentally did just now. So in this vehicle, we've got anti-lock braking functions. So if we brake too hard, we shouldn't skid. So braking too hard actually is kind of a thing of the past. Yet, of course, if we accelerate too hard, we'll still spin the wheels. There's no way for our braking system, which is monitoring the wheels, to let the ignition controller know that it's got to do something, perhaps to adjust the engine power and thereby regain traction. So, step on again. We have ECUs here. We have software now as well as the electronics. And we want to be able to share data between our braking controller, our ABS controller, and our ignition controller specifically to get our traction control function. So we're going to introduce a single CAN bus, which for the sake of simplicity, we'll call vehicle CAN. And our ABS ECU is now reliably able to ask the ignition controller to change ignition timing, and this reduces the engine output if the ABS ECU detects that wheels are spinning, and this means we have got traction control alongside our anti-lock braking control. Of course, we wouldn't just have these two ECUs in our vehicle. We probably also will have others, which we'll come to. We also maybe are worried that some people feel that the traction control function that we've put in will interfere with their ability to enjoy and drive the car. So we put in a switch that allows the driver to turn off the traction control function if they so desire. And we also add a diagnostic connector to permit us to perform the mandatory OBD functions that we need to have in the vehicle to be able to sell it, because we have an emissions relevant system here, the ignition control. And we may also want to do other diagnostics, for example, with the ABS ECU, because perhaps, maybe eventually, one of these wheel speed sensors could break or the wiring could become damaged, which would affect our ability to provide our anti-lock braking function and also the traction control function. So other diagnostics outside of the scope of emissions relevant OBD. This is the early 1990s, very roughly. Let's move on a little bit more. We keep on introducing ECUs and we improve and integrate some functions. So our ABS ECU becomes an electronic stability control ECU. And we merge our ignition and fuel injection controllers into an engine management system controller or an engine management ECU. And each time we add a vehicle function, we're adding an ECU until we reach the limit of what we can connect to a single CAN bus. Now, there are two limits we may need to consider here. Firstly, there is a limit to the number of connections we can make to a CAN bus in terms of number of sending and receiving devices. And also, of course, there's a limit to the amount of data that we're actually able to send via a single CAN bus. And if we hit either of these, we've hit the limit for a single CAN bus. And at this point in time, we need to do something a bit different. So at this point in time, late 90s, early 2000s, we start to see the introduction of gateways, which effectively allow us to cut up the CAN buses into a number of different buses where we are less likely to prevent us, I should say, from hitting the limit of the number of ECUs or the amount of data that we're able to send. And the job of the gateway now is to route, this specific terminology of routing data between the networks, and the torque reduction request that we're sending from our ESC ECU now to our engine management ECU is one of these items which is going to be routed by that gateway between the chassis CAN bus and the powertrain CAN bus. So that's kind of we're 2021 now, 20 years ago roughly. So the first 100 years or so of the car, there was really no electronics at all. Then in the 80s, we got some electronics, 90s, early 90s, we introduced CAN. We've now, in another 10 years, suddenly we've got a lot more going on. And we keep on introducing stuff into the vehicle, of course, with new ECUs and new networks, such as FlexRay for more advanced chassis control functions. So, for example, electronic suspension control, electronic power or electrically controlled power steering. And also, we may introduce something like LIN. And LIN allows us to have smart switch packs. So if we have switches, they might have lots of wires running to them to various ECUs. What we can do is we can replace many of those wires with a single wire which takes lots of switch statuses via communication. And our traction control off switch is one of those switches. Its status is now communicated via LIN. And in our simple example, we're taking the LIN bus to the gateway, which will then gateway that data, route that data along with the other data that we choose when we're designing our networks, between the body LIN and the chassis flex ray. And the torque reduction request from the ESC is sent deterministically, so according to a really tightly defined schedule on the chassis flex ray bus, and the gateway then is able to send that to the powertrain CAN for the engine still. So we haven't changed our traction control function in any way, we've just changed how it's realized in the vehicle. So we have effectively a virtual switch now. It's a physical switch we hit, but the wire between that no longer, and the ECU no longer exists. It's now communication, it's data that we're sending via a communication network instead of a real physical wire. Now, it's worth mentioning that at this point in time, we're in the mid, maybe late 2000s, and many of our ECUs, including the gateway ECU, and probably actually all of the ECUs that are on the chassis flex ray network, are going to be based on the AutoSAR Classic platform. So this is where we start to see AutoSAR Classic coming into the vehicle. And if we just step on a little tiny bit further into the very early 2010s, this is the kind of point where maybe we start to introduce a slightly fancier user interface into our vehicle. We have a touch screen, for example, with entertainment system, where we've got some fancy graphics or animations, and to transfer new graphics or animations using CAN to this system might take many, many hours. So at this point, to avoid that long duration for transfer, we introduce Ethernet for software updates in particular, and some other diagnostics, using a technology called Diagnostics over Internet Protocol, DoIP or DoIP, it's also called. And this gives us the ability to get shorter transfer times, shorter download times. And DoIP is initially, at least, standardized as ISO 13400 parts 1 to 4 in 2011. So you can see this really is at the start of the 2010s. And alongside this, of course, our infotainment system itself may use Ethernet to connect to maybe a hard drive or DVD drive, where audio and video data is able to then be streamed over Ethernet between a separate part of the infotainment system to the screen, which is in the front. It used to be quite common that you'd have a DVD drive or a hard drive in the boot, or maybe kind of buried somewhere behind the glove box, and you obviously then we need a high-speed data link between that and the screen where we want to see things in our vehicle. It's important to note that although we've introduced diagnostics over Internet Protocol, which is Ethernet-based diagnostics, we need to keep CAN, at least for the time being, to meet OBD regulations. So OBD regulations still require us to use CAN, even if we can use the faster, fancier Ethernet for our diagnostics we want to do outside of OBD requirements. That is everything we're going to talk about today. So we've got up to within 10 years of the present day, very roughly. Over time, it should be clear to you that vehicle EE systems have become much more dependent on network communications to allow the software in ECUs to share data. And the sharing of data between that software is how we realize our functions, such as traction control and other things that we interact with on a daily basis when we're in a vehicle or nearby a vehicle. The changes have been relatively gradual up to now. As we said, first 100 years, really very little changed at all. And then in the last, in the space of 20 years, we went from some electronics to suddenly different network technologies linking up quite a lot of electronics, hundreds of ECUs potentially, with even the arrival of Ethernet around 10 years ago. So in that kind of 20-year space, 1990 to 2010, a lot happened. And these changes are accelerating as well. And that's what we're going to look into in our next episode. The in-vehicle networks that we have in vehicles, of course, are the enablers for new capabilities that are obtained through the sharing of data. And the different network technologies, such as CAN, LIN, FlexRay, and Ethernet, were introduced to provide different capabilities needed in vehicle EE systems. So we don't take out CAN just because we've introduced Lin and FlexRay. We still keep CAN for some things, maybe not all the things it was doing when we replaced the chassis CAN with FlexRay, but we still have it there. And when we introduce Ethernet to start with, we still have CAN, Lin, FlexRay in our vehicle. Now, if you want to get more information on in-vehicle networking technology, you might want to take advantage of Vector's free e-learning on in-vehicle networking, and also the AutoSAR Classic platform, which you can access via our website. And also we provide detailed technical training on these and many other related topics. If you go to the Vector website, you can also find details of our data-centric engineering platform for the design and analysis of software and the related network communications in vehicles. This is called Prevision. We also, of course, have embedded software that matches the AutoSAR Classic specifications, which is called Classic MicroSAR. And we have tools for the simulation and testing of in-vehicle networks and individual ECUs called Canoe. Make sure that you join us next time to step into the present day and look into the future in episode F11, How is the Jigsaw Evolving? As always, if you have any questions on this episode, any suggestions for a future episode or a topic you'd like to see covered in an episode, please leave a comment wherever you've seen this video. Please subscribe to the Vector YouTube channel, where you probably have found this video. And also remember, you can contact us via email with our special email address, engineering.jigsaw@vector.com. I'm in Cunningham for Vector GB. We'll see you soon for episode F11 next time. Bye.